Thanks, Emma. Well, good morning, everybody. In this session, we will be going over the various Oracle technologies and describe how the LSI Nitro products can increase the performance of each of them. First, Oracle the company. Oracle was founded on the database software that transformed the industry into what it is today. Oracle is the leading software provider for enterprise solutions, and these are some of the stats that show how different companies use Oracle and all of its technologies. And according to Gartner, Oracle remains the #1 worldwide relational database software revenue share for 2012. So some of the technologies we'll be going over today is the Oracle database, the MySQL database, and MySQL is the most deployed open source database. Berkeley DB, Berkeley is a library that links directly to an application, and the application makes simple function calls rather than sending messages to a remote database server. NoSQL, which is built upon the Oracle Berkeley Java Edition. It is a distributed, highly available key value storage, and it's suited for large volume, latency-sensitive applications. And Berkeley with NoSQL is one of Oracle's big data offerings. Oracle RAC, it's a shared everything cluster compared to most other databases, which are shared nothing. And we'll go over Oracle Linux and UEK. Oracle Linux is the Red Hat compatible Linux, and UEK is their unbreakable kernel. And the unbreakable kernel has been modified to take advantage of flash technology. Oracle VM, it's Oracle's equivalent to VMware. And the Nitro products can provide performance benefits to any one of these Oracle technologies. And a brief overview, with Oracle 11GR2, there's different editions of the database. One is Enterprise and the others are Standard. The Enterprise is the same edition used in Exadata and the database appliance. And it gives the DBA or the Enterprise the extensibility to meet performance administration needs. Some of these features, Active Data Guard is included in the base Enterprise Edition, but partitioning, compression, and RAC are options that you can get licenses from Oracle. The Standard Edition, it's the same database engine as the Enterprise Edition, but you're not allowed to extend it with those additions or up above, like partitioning and RAC. And there's Standard Edition 1, which is limited by the number of CPUs and the storage capacity. So what are the customer's pain points today? What's the opportunity for that? So meeting performance SLAs with constant data growth is very hard. Most databases are I/O bound because of the slow hard disk latencies. Disk storage performance has lagged performance gains in CPU and network speeds. Flash is still expensive per gigabyte. Storage systems develop hotspots over time. Database administrators don't have the time to constantly tune the storage system to eliminate these hotspots. And there's some sites out there where rapid response time is critical to customer satisfaction. 57% of online shoppers will wait up to 3 seconds before abandoning the site, whereas 79% of the shoppers who are dissatisfied with website performance are less likely to purchase from that site again. So all enterprise databases, Oracle, SQL Server, MySQL, while offering their own advantages and features, are all faced with these challenges. So since flash is expensive per gigabyte, but very cheap for IOPS, you want a hybrid storage system, mixing flash with hard disks. So flash creates a performance inflection point, meaning it provides thousands times greater IOPS than hard disk, whereas hard disks still provide the best solution for high capacity storage. So Nitro Intelligent Cache Solutions. So where Nitro fits in is between the server and the hard disk. And the Nitro technology actually looks at LBAs on disk and caches the hot LBAs on the flash device. So over time, the hot data will be on flash and subsequent access will be retrieved from the flash. That's where you get your performance. So WarWrite is a compressible technology that actually saves on the wear and tear of the flash. It compresses the data so you don't write as much data to flash. And DuraWrite actually realizes 12 to 20% compression in an Oracle database. And some of the other compression stats are JPEGs at 4%, websites 30 to 50, and Office files like Excel and Word up to 90%. So what are the benefits of introducing Nitro into an Oracle Enterprise database? So we provide intelligent server-based flash cache to unlock database performance. Our goal is to remove the I/O bottleneck. In the enterprise, today hardware is a commodity, meaning it's much cheaper to buy the hardware than it is to buy all the licenses of a database. And it's much more appealing to look at the cost of Nitro in relation to the total cost of the database server, meaning hardware and software. So you don't want to look at putting a $5,000, $10,000 board in a $10,000 server. You're putting a $10,000 board in a $600,000 server. So, for example, if you're purchasing a $10,000 acceleration board and you increase the database performance by 5 to 20 times, that $1,000 is very small cost in relation to the total picture of the database server. And using Nitro, we leverage the money already spent on the back-end storage. We're not replacing that. So we have 3 different methods that we can enhance Oracle performance. The first is implementing our Nitro drive with Oracle Smart Flash Cache. An Oracle Database Smart Flash Cache is acceleration code built into the Oracle Enterprise Edition. What that is, it is an extension to the Oracle buffer area in the SGA. Oracle Smart Flash Cache is available only in R11G R2. Any other database releases, 8, 9, 10, Standard Edition, or Enterprise Edition, LSI products, Nitro XD or Nitro Mega RAID, we will work with any of those other platforms. So an overview of Smart Flash Cache, it acts as a second-level cache to the database buffer cache. A rule of thumb is that buffer cache or the flash cache is 2 to 10 times the size of the database buffer cache. How the data gets put onto flash, it's fed by evictions from the buffer cache. It accelerates random read, intensive workloads. Database Smart Flash Cache is rack compatible. And in order to meet requirements and the capacity Flash, you can mix one or many Nitro warp drives in the system. And Oracle Database Smart Flash Cache requires an Oracle Linux or Oracle UEK or Solaris operating systems. It will not work with Red Hat, SUSE, and others. So the second option we have is Nitro XD, and that works in conjunction with the warp drive. And we front-end hard disk drives arrays, whether it's fast fiber channel, iSCSI. So in the stack, you have a database on the top, you have a file system, you have our Nitro XD caching software, and then the warp drive board. And any read to the disk system, we determine if that's hot data or not by the number of times and so forth that it's read block. And any hot data will reside on flash, on the warp drive. Cold data is just passed through. Multiple warp drives can be used to create a single cache group if you need more cache capacity. So Nitro integrates with existing storage, whether it's a DAS or a SAN array. A nice feature about this is zero admin overhead. It's automatic self-starting and self-configuring. No tuning required. Some of the benchmarks we've done in the lab and what other third parties have done, XD gets great performance gains when running with Oracle TPCC, TPCH. And in this example, we show a 10 times improvement in response time and 10 times in the number of transactions per second. So XD eliminates I/O bottlenecks, whether it's going against a SAN or a DAS. One of the benchmarks we did in our labs, this is going against an iSCSI SAN. On the left side is the baseline using hard disk, and on the right, all we did was implement XD, no database changes, no storage changes, and we got a 10x improvement. It's very easy to do, no database changes. The DBA doesn't even know that we're caching. Here's a graph. We did a benchmark on how many users can we support when response time is under 3 seconds. So we created a server, and we did a hard disk baseline, and we ended up with 1,750 users before transactions started getting above 3-second response time. And the cost on the left side, you'll notice for hard disk is $1.29 per transaction for 1,750 users. So what we did is we implemented XD, no database changes, and we allowed the system to grow until the number of users exceeded 3 seconds. Well, we got up to 6,000 users. And then at 6,000 users, the transaction cost is 9 cents. So a savings of $1.29 or $1.20 just by implementing XD. And here's a cost summary of that last screen. You'll see the server hardware, $16,000, software is almost $400,000, and hard disk number of users is 1,750 before it exceeded 3 seconds, 6,000 users for Nitro, and these are the cost savings that you would get by implementing Nitro. Not only are you able to support more users, but that limit of 3 seconds, we were able to save much more per transaction. The third area that we can provide benefit in is using Nitro MegaRAID. And Nitromegarate, we've sold hundreds of millions of cards, Megarate cards, for the last 20 years. And Nitromegarate is a very cost-effective way to increase database performance, because now the Megarate cards have onboard cache. So Megarate is a lower cost solution compared to short stroking hundreds of hard disks, can be used with any Oracle database release or addition, and is designed for easy integration into an existing DAS storage. And the stats on the left, you'll see that with the baseline hard disk, we got 1/3 of a second response time. On the right, introducing Nitromegarate, we increased performance almost 10 times. So very good performance, and we got much better. Again, no DBA changes. They're not aware that we're even caching. Here's the benchmark we did in the lab with MySQL, and you'll notice we got a 5x jump in performance, and each one of these lab benchmarks we did have different sets of hardware, different sets of storage, so you can't compare each one to equal, like MySQL versus Oracle, because the storage and the setup was different. So LSI came out with a product called Nitro Predictor. And what this does is we can run Predictor on a system, on an existing production system, and it traces all storage I/O. And we can determine by that trace how our products will benefit the user. What we show is how much data is hot, what's the read-write I/O ratio, is it 60% reads, 30% reads, and then we can base our prediction of how much performance gains you will get and what type of hardware you will need to satisfy that storage capacity, that flash capacity. And it's a no-cost pre-sales tool, and the user can get one screen, but if you work with our FAEs, we have a more advanced feature, and we get much more different reports when working with our FAEs. So what are the benefits from implementing Nitro into a database environment? We don't require any DBA involvement. We don't require changes to the database. We don't require any changes to the storage system. We work off of virtual disks, VDs, or LUNs. We work with any database without any additional licenses. We work with SAN or DAS block storage devices. We don't interfere with storage mirroring, snapshot technology, because XD uses write-through. Write-through means what's in flash is transparent to what's on disk. We can use single or multiple Nitromegarate cards to meet capacity, or use single or multiple Nitro warp drives to meet cache capacity. And we support most of the popular operating systems. So things to consider when implementing Nitro. In an Oracle environment, it involves small random reads and writes. In a database, in a data warehouse environment, the database access involves full table scans. Full table scans means it reads the data, the whole table from beginning to end. For a data warehouse or analytics environment, the Nitro warp drive or the Nitromegarate cache capacity needs to be larger than the size of all the tables that are involved in the full table scan, as well as any other hot data. Whereas in an OLTP system, since you're doing random reads and writes, we've seen 15 to 20% of the capacity on disk that's needed for the flash, because not all database data is hot in an OLTP environment. And since data warehouses environments can be quite large, this might require multiple warp drives or MegaRAID cards for the cache capacity. And what we've seen is in a data warehouse environment, if the cache capacity is smaller than the total hot data, all the full table scan tables and any other hot data, performance can actually be worse than using just hard disks. The reason for this is the cache is being overwritten while the query is executing. The client also needs to be aware of write-back caching when the back-end disks are being mirrored or replicating from hard disk to another hard disk, because data in the cache is not transparent for data on hard disk. It takes seconds to minutes before they're transparent. So right now, write-back caching can be enabled in Nitro MegaRAID, where Nitro XD, it currently uses only write-through caching. And write-back, Nitro MegaRAID can be enabled for write-back or write-through, depending on what the environment requires. So if a client is using any of the hard disk replication tools, it's safer to use write-through caching. Also when using Nitro Warp Drive with the Oracle Database Smart Flash Cache feature, our predictor tool won't work because the predictor tool uses or looks for hot LBAs, whereas the Oracle Smart Flash Cache is an eviction system from the buffer cache. So completely different caching technologies. So really our predictor tool won't work in this environment. And any questions?